So let's look at a full list of time value of money scenarios. So we see three patterns. There's a single payment, which is what we just did, with a payment in the future or now, PV or FV. The second is where we have a series of identical payments. And under this scenario, they're called annuities, where every year you get a certain amount, or every month you get a certain amount, or every quarter you get a certain amount. Right? Those are called annuities, where there's a regular interval and a regular payment. So that very rigorous pattern is also one where we can use formulas to determine the valuation. Again, the present value of future set of these annuity payments, or the future value of a series of annuity payments into an investment. So similar to what we did for a single payment, the same holds if instead of having one payment, we have a series of regular can't miss payments. So those called annuities or series. And the third scenario is uneven. It goes up, it goes down, it goes positive, it goes negative, and you have to make some sense out of that mess. Right? So we're going to look at all these scenarios and show you how to compute the various factors that come through time value of money. All right, on this page, we see a recommendation I would have to you anytime you do a present value calculation, and that is to visualize the cash flows. And I'll explain what I mean by that. Notice that on the left side, we have this 2x2 matrix where we have present value in column, future value here, and then on the rows, we have a single payment versus annuity. What we've been doing so far is simply single payment, where we had a payment that is made at the beginning of the period or at the end of the period. So to get the PV, we would do a function of bringing back the future value to the PV. And the flip side is we have the PV and we're figuring out the future value. And what we have here is the function inside Excel where we can have Excel do that work for us. And it is PV, rate, number of periods, the payment, the future value, and the type. Now you might say, wait, this is more parameters that we had before. Let me explain that. Since this is a general use formula, we have more things than we need. If we only have a single payment, this payment becomes 0, and this last payment, the future value, is the FV. The type gives us the flexibility on telling the computer when does money move. Does it move at the end of the period or beginning? In the vast majority of cases, when we do calculations, it's the end of period, and that's why that's the default. So if you don't enter anything for this particular parameter, just close parens and hit enter. It'll just assume that you want the end of period, which is fine. And this is how we'd compute it using Excel for the present value of a single payment. Likewise, for the future value of a single payment, it's this one. It's the future value, which is what we're looking for, rate, period, payment, present value type. Now notice this PV changed from FV to PV because now we're computing the FV. So these two compute using Excel functions what we did manually, or I guess arithmetically, with the formulas. Now the bottom are these annuities where you get a series of payments. That's what these little green lines represent, is you get these whole series of payments, and that's what is the PMT. And here we would have equals, present value, rate, number of periods. Now you do have a payment, and if there were another lump sum payment at the end in addition to these regular payments, you would enter FV here. If not, don't sweat it, put 0. Same thing here. What is the future value of an annuity? Then we have a series of payments, and it's worth a bunch of money at the end. Now notice in all these cases, we have some that are negative numbers, some that are positive. And what that represents is I pay money out of my pocket now, like a savings account, and then at the end of the period, I get money, a positive amount. The flip side is that I would pay money out, or I would get money later, which means I have to pay money now. So that's why there's always a negative and positive in Excel when they do TVM calculations. Same thing on annuity. If I pay money out now, then I can get a series of payments in the future. In fact, there are investment products called annuities where that exactly is what happens. You pay money, then you get a series of payments. The other scenario is you pay money during the period and then you get a large amount at the end. This is like you're saving for a future down payment or a major event, right? So this is the example of annuities or series, and they both use the same Excel functions. PV, whether it's for a single payment or annuity, notice it's the same formula. And future value, whether it's single payment or annuity, notice that's the same formula, right? So that's the visualizing the cash flow and then tying that cash flow into the appropriate function inside Excel. The other, which I just put off to the side, is an uneven cash flow where it jumps around. Here, at least it's always rising. But it can go up and down, positive, negative, and be uneven, right? So these scenarios comprise the types of cash flows you're likely to encounter, and then you have to figure out what is the present value, future value.